Hey everyone, I saw a lot of questions floating around in the discussion and through email about the StatCrunch assignment tonight, so I just wanted to show you a different example. This is one of the data sets that I pulled off of StatCrunch, so I'm just going to pick some variables to kind of play around with here. What these are home runs by people, and so I'm going to focus in on two quantitative variables that we have here. So one of them is the true distance, so how far the ball goes, and then another one is the speed off of the bat. So it's an easy assumption to kind of make that the speed that the ball goes off of the bat would correlate to how far the ball goes. So these are going to be my two variables. So I'm going to use the speed off of the bat to help predict what the true distance that the ball travels is. So just real quick here, we're going to go to data. Well, first off, let me show you a scatter plot. So we're going to go to graph, and then we're going to go down here to scatter plot. And let me move this over so we can see the names of these. So again, we're using the speed off of the bat as the predictor or the explanatory variable. So that's going to be our X column. Our Y column is going to be true distance because that's what we're trying to predict. Off the other things, we don't really need to change anything. I'm going to let it kind of do its thing and pick what it wants to do. If we need to go back and change anything, we can. So when we hit compute, so this is the scatter plot that we get. Now obviously your scatter plots for your data sets is not going to be as crowded as this is. If you scroll down here, you'll notice that we have a lot more data in this data set than you do in yours. So there's over 4,000 pieces of data here, where in your data set we're not near that. I don't think that we're near that many. I think we're around 900 or so. So the scatter plot that you look at here, we see that it is linearly correlated. We see that the dots are kind of trending in an upward pattern, if you can see my mouse moving there. And we would kind of expect the correlation to not be real strong, but there definitely is a linear pattern here. You can see that the dots are going up as the speed off the bat goes up, right? So we can see that. So that gives us justification to kind of run the regression. So from there, we're going to go into our stats. We're going to go to regression, and we're doing simple linear here. Simple linear refers to one explanatory variable with the response variable. So, and we're doing linear. We're assuming that the dots are following the path of a line. So we're not going to mess with the other ones right now, but there are other ones. Multilinear just means that you're using more than one explanatory variable, which in this case would probably be beneficial, right? Think about the angle that the ball comes off of the bat, where the ball apexes, which is the other column that you see here. But for right now, for the purposes of this, we're just going to do simple linear. So once again, we've got to choose our X variable. Let me move this over. Again, we're using the speed off of the bat to be the explanatory variable, so that's our X. And then our true distance is our response variable, and that's going to be our our Y variable. So you see some other things down here. You see that you can do a hypothesis test. We can go ahead and allow it to do that. We're not really going to be concerned with that. It's just going to do the hypothesis test to make sure that these variables are in fact, this variable is in fact helping explain the true distance. The other thing that you might see down here, if I can get it to work, is that you can get it to predict. So you have a prediction example on your StatCrunch assignment. So I'm just going to pick a speed off of the bat. I'm just going to pick 100. So what it's going to do is it's going to predict how far the ball is going to go if I have a speed off of the bat of 100 miles per hour. The other things are just options that you can pick. You don't have to pick any of these for our purposes right now. We're just going to run the regression. Again, this prediction thing is an option. I'm just doing that to show you that you can use it to help predict an outcome that you're curious about. So we're going to go ahead and hit compute. And you'll see that we get this. Now the regression equation is right here. I don't know if I can highlight it. There we go. The regression equation is right here. You'll notice that it writes it in terms of the variables, so it doesn't write x's and y's. This is your slope here next to the speed of the bat, and then your y-intercept is the constant that's added. So your slope is 3.8984353. Your y-intercept is the negative 6.8, and so on and so forth. Here is the hypothesis test that it's running for the slope and the y-intercept. You don't really have to pay attention to these. The slope is the one, if anything, that you want to pay attention to. If you remember hypothesis testing, the fact that the p-value is less than 0.05 in this case for the slope is a good thing. The y-intercept, it's not going to make sense, which is why we're getting a p-value that's greater than 0.05. What I mean by that is if you can't really have a speed off of the bat of 0, so that's why you're seeing a negative y-intercept, which is why you're getting the p-value that's greater than 0.05. But again, don't worry about that. Oh, in any case, so the regression equation that you would want to write down is here. So there's that. And then you can see some of the other things. You see your correlation coefficient here. You see your r squared here. And then down at the bottom, you'll notice that it does our prediction for us as well. So if we have a 100-mile-an-hour speed off of the bat, then we expect the ball to travel 383.04 feet. Now you'll notice that it also does confidence intervals and things for that as well. Again, for our purposes, you can just focus in on the prediction. In any case, guys, I hope this helps get you started on your StatCrunch assignment. If you have any questions or anything, by all means, let me know.